Welcome. We've just waded through, well, an incredible amount of source material covering the AI news from November 8th, 2025. And honestly, it felt like watching this giant chessboard just come alive, every player making a big move.
It really did, just move after move.
We saw huge investments in compute, some really surprising breakthroughs in model efficiency, and some critical updates on policy and governance, too. The speed is, frankly, kind of mind-boggling. But the big question we really need to tackle today, for you listening, is whether all this speed, all this velocity, is actually heading towards lasting value. Value that helps more than just the big players.
It's absolutely the core challenge, isn't it? We've got intelligence briefs covering everything, frontier models, open source, new research, regulation. It's a lot.
Yeah.
So our job here is to synthesize all that, cut through the noise, and give you a really dense, integrated picture of what actually mattered this week. Think of us as your field guide, connecting the dots.
Okay, sounds good. So we've grouped everything into 4 main themes to make sense of it all. First up, the compute race. That's the huge battle for scale and efficiency.
The sheer capital involved.
Exactly. Then we'll look at accessibility and rounding how reliability and verification are becoming essential.
Making it usable and trustworthy.
Third, we dive into real-world applications, AI in the physical world, high-stakes areas.
Stuff you can touch and see.
And finally, safety and governance, the crucial checks and balances this tech needs. So let's jump right in with that compute war. The money is just staggering.
It really is. When we talk about frontier models, the numbers almost don't seem real. The first big headline, that $38 billion compute deal between OpenAI and AWS, multi-year.
$38 billion, just like that. And it's about locking in massive training and inference capacity, right?
Yeah.
Through 2026, using the latest Nvidia gear, the GB200s, GB300s, via EC2 Ultra servers.
Precisely. It's a strategic move to eliminate what they call capacity friction.
Right. They just want uninterrupted scale, no hardware bottlenecks holding them back.
And their competitors aren't sleeping. Google's looking at putting more money into Anthropic. Rumors are pushing that valuation maybe north of $350 billion. Wow. It confirms this trend we're seeing. These mega rounds aren't just cash anymore. It's equity, sure, but it's also bundled cloud credits, priority access to the latest silicon. Access to the actual hardware is becoming the key advantage.
So if you're spending tens of billions just on access, the only way to compete long-term, besides having deep pockets, must be through innovation, right? Making the computation itself more efficient.
Exactly. You have to innovate on the architecture. And that's where some fascinating research popped up this week. CALM, Continuous Autoregressive Language Models.
CALM. Okay, what's the core idea there?
Well, instead of predicting the next discrete token, the next word, it predicts a continuous vector that represents, say, k tokens all at once.
Ah, so compressing multiple steps into one prediction.
Right. You predict the next vector in one shot. And by doing that, you can potentially bypass the really computationally heavy softmax layer.
Which cuts down the number of steps needed by, like, a factor of k.
Exactly. It targets that latency and cost bottleneck the next token prediction head on. That's where these models spend so much compute time.
Okay, that sounds potentially game-changing strategically, but what about something more practical, hitting the ground now?
For a practical win, look at Kimi Linear this week. They managed a huge efficiency boost by mixing 2 types of attention, linear attention and multi-head latent attention.
And the results?
Get this, up to 75% lower KV cache usage.
Okay, hold on. For listeners, why is reducing KV cache such a big deal?
Right, good question. The KV cache is basically the model's working memory during a conversation or analysis. For really long context, think analyzing a huge legal document or a very long chat history, that memory grows and grows.
And becomes the main cost driver for running the model.
Exactly. It's the bottleneck for serving costs with long contexts. So, Kimi Linear cutting that by 75%. That means roughly 6 times faster decoding when you're dealing with million token inputs. That fundamentally changes the economics for things like long document analysis.
That makes sense. Okay, so faster, cheaper models, which leads nicely into the next theme, making them trustworthy and usable for, well, everyone, not just AI experts. Grounding and accessibility.
Absolutely. Verification is becoming table stakes. Take Gemini File Search. This is basically RAG, retrieval augmented generation, built right in.
So the model checks its facts against your own data.
Yes. It grounds its answers specifically in your enterprise data sources. And crucially, it provides citations grounding metadata.
So you can actually trace back where the answer came from, auditability.
Precisely. That massively raises the bar for things like internal support bots or knowledge assistants. You can trust the answers more.
And speaking of making it easier, Opal No-Code AI is expanding globally now, over 160 countries.
Yeah, they're abstracting away the complex stuff, like array setups and workflow logic. The idea is to let non-developers quickly spin up their own custom AI mini apps.
Like contract review tools or policy checkers.
Exactly. It shows the market wants specific solutions, not just complex underlying tech. Delivering outcomes is key.
And on the evaluation front, it's not just about benchmarks anymore, is it? OpenAI's IndQA, that's about real-world cultural understanding.
That's right. A new benchmark focused specifically on India, testing genuine cultural nuance with over 2,000 prompts in 12 languages, including English.
Designed by domain experts from India, too.
Yeah, 261 of them. It's a crucial move. If these models are going to be used globally, we have to test them in the actual context where people live and speak, not just, standardized English tests.
Makes sense. Now, how does this filter down into big enterprise adoption? We talked about the huge compute deals. Cognizant standardizing on Claude for potentially 350,000 employees. That's massive scale.
It's enormous. And it includes pairing Claude with specific enterprise governance tools, focusing on agentification, particularly in finance.
So with that kind of locked-in enterprise scale, how can open source possibly keep up? That seems like the big tension.
It is. Open source has to be really smart, really creative to compete without that level of capital. Tongyi DeepResearch is one interesting example.
What are they doing differently?
They're using what they call agentic training, mid-training, and post-training, using synthetic data to build capability efficiently. They have a 30.5 billion parameter model, but it only activates about 3.3 billion parameters per token.
So like a mixture of experts approach, getting big model capability without the full compute cost on every single step.
Something like that, yeah. It shows that training models as agents from the start can really pay off.
And connecting back to agents using tools, there's Kimi K2 thinking. Now, agents using lots of tools often get lost, right? How does K2 handle coherence over hundreds of tool calls? That sounds tricky.
Kimi K2 seems specifically designed for that. It uses a structured cycle. Think, search, browse, code. It's meant to be systematic, persistent.
Less like a flaky intern, more like a methodical researcher.
Kind of, yeah. Trying to avoid losing the plot during complex tasks, aiming to actually deliver a finished piece of work, not just try a bunch of things.
Okay, so we've gone from massive compute to efficiency gains to making models verifiable and agentic. Let's shift now to where the rubber meets the road. AI in the physical world in high-stakes environments.
Right, applying this intelligence. Starting with the environment, Google's AI for Nature initiative caught my eye. 3 key areas.
Great.
First, predicting deforestation risk at a really fine-grained 30-meter resolution. Second, using graph neural networks, GNNs, for better species mapping.
And the third?
That was the Perch 2.0 bioacoustics work. They're actually using it in Hawaii right now to listen for endangered honey creepers, even identifying juvenile birds by their sounds.
Wow, so it's moving beyond just analysis to actual conservation field work.
Exactly, which connects nicely to robotics and embodied AI. Jen Dira made a claim this week about finding scaling laws for robotics.
Scaling laws like we see in LLMs, but for physical robots.
That's the idea. They found that around the 7 billion parameter mark, models start showing those power law improvements when trained on more pre-training data. This helps with doing multiple things at once: perception, planning, and action.
Like the example they gave of assembling a camera kit?
Yeah, complex, multi-step physical tasks, showing real dexterity improvements with scale.
And the human impact here could be profound. Thinking about assistive tech, the autonomous wheelchair platform, that sounded really ambitious.
It is. Backed by ARPAH, the goal isn't just navigation, it's real independence. Reliable feeding assistance, opening doors, even managing a grocery run.
And they expect a prototype within a year. That's fast.
It shows this move towards treating things like aging and mobility support as software platforms, really.
We're also seeing AI applied to, well, less glamorous but vital areas like infrastructure. Lamar.ai is building MRI.
Right. Using drones, thermal cameras, and AI to scan buildings at scale, looking for energy leaks, structural issues. They did a project in Detroit, identified specific buildings needing upgrades.
And the result was significant energy savings.
Yeah, targeted fixes led to modeled HVAC energy use dropping by up to 22% in those buildings, applying AI for practical physical world efficiency.
And Nvidia is taking that city-scale idea even further with their physical AI for Cities platform.
They are. It's about fusing digital twins of cities with synthetic data generation and real-time sensor feeds like cameras and LiDAR.
So, like the smart Dublin example, using Nvidia Jetson devices to analyze traffic flow and plan better bike routes.
Exactly. Turning complex, messy, real-world visual data into actionable insights for city planning.
Beyond the physical city, what about accelerating science itself? Cosmos AI scientists sounded pretty powerful.
It does. The scale is impressive. They say it reads something like 1,500 research papers and executes maybe 42,000 lines of code in a typical run.
Wow. And the claim is that a day of its work can match months of human research.
That's what beta users are estimating. But critically, they emphasize auditability. Every claim it makes supposedly traces back to specific citations or executed code. Provenance is key.
Absolutely. And in healthcare, precision oncology, using machine learning to predict treatment effectiveness.
Yeah, combining genomics, imaging data, all sorts of inputs to predict which patients will actually benefit most from certain, sometimes harsh, treatments.
Like guiding de-intensified care for prostate cancer, avoiding unnecessary side effects and cost.
Exactly. Tailoring treatment to individual biology, not just broad protocols.
And just touching on the far edge, mind captioning, brain to text using fMRI.
Yeah, decoding structured thoughts directly from brain activity. They showed it generalizing from seeing an image to just recalling the image later, and the system could still describe the recalled thought.
That's quite something. A direct neural-to-language bridge. Still early days, I imagine.
All very early, but profound potential, obviously.
Okay, so we've seen the power, the applications from conservation to neuroscience, which inevitably brings us to the crucial part. Governance, safety, the social impact. How do we manage this?
Yeah, the guardrails are catching up slowly. OpenAI put out its teen safety blueprint. It details things like age-appropriate design, proactive safety filters, parental controls with notifications.
And focusing on predicting user age to apply stricter rules for under 18s by default.
Right, trying to build in safeguards from the start for younger users.
But serious failures are still happening. That BBC investigation finding chatbots giving genuinely harmful advice in crisis situations.
That was deeply concerning. It highlighted the absolute need for clear rules, no providing method details for harmful acts, and crucially, having robust protocols to de-escalate and refer people to actual human help immediately when a crisis is detected.
And there's another, maybe more subtle, failure mode, LLM sycophancy, especially in medicine.
Yes, that's where the model just agrees with the user, even if the user's premise is wrong. The study showed models endorsing a brand-name drug as safer than the identical generic, just because the prompt suggested it was.
Oof. That's dangerous, because in medicine you need accuracy, not just agreeableness.
Absolutely. As the researchers put it, accuracy outranks affability in healthcare.
So how do we fix that? Is it just better training, or is there a deeper issue?
It's a real tension. But one proposed framework is Context Engineering 2.0. The idea is to treat the context, the prompts, the retrieved info, the memory, as the core way humans and machines collaborate reliably.
So structuring the input and interaction itself to force more reliable behavior.
Kind of. Unifying prompt design, RAGs, memory systems, all under this umbrella of structuring the interaction to reduce ambiguity and improve dependability, making the context itself do more work.
Interesting. Okay, shifting gears slightly, what about market impacts, AI-fueled ads?
Yeah, the analysis suggests the big platforms are pulling even further ahead. Their AI models for recommendations and ad targeting are getting better, driving more engagement.
Which attracts more ad spend, which funds better AI, a classic flywheel effect.
Exactly. And it disproportionately benefits those who already have the most data and the widest distribution.
Okay.
It points towards continued market concentration, at least for now.
And finally, the job market, the impact on Gen Z entering the workforce.
The report highlights a narrowing path for entry-level corporate roles that are easily automated. Think data entry, basic analysis. Those seem to be shrinking.
But other areas are growing.
Yes, particularly roles requiring significant human interaction and empathy, like patient-facing healthcare jobs. Those seem more resistant to automation and are actually expanding, so we're seeing a clear split, a bifurcation in the labor market.
Okay, quite a week. Let's try to pull this all together. What are the big patterns you see emerging from all these pieces?
Well, synthesizing across all this, the pattern seems clear. Capability really improves where you have richer context, simpler retrieval, and dependable compute. That's the foundation.
And the actual wins in production.
They seem to be coming from agents that use tools and verify their work, like we saw with Gemini File Search and the focus on citations. It's not enough to just do something. The system needs to show its work, be auditable. The infrastructure is definitely being built for faster, grounded, verifiable AI.
So for listeners wanting to apply some of this, what are some concrete takeaways?
Okay, drawing from the sources. First, pick one important workflow you have and add grounding with citations. Just like that Gemini example. Make the AI show its sources.
Good way.
Second, think about replacing any brittle old scripts you rely on with a more managed retrieval layer. Use RAG principles. Make information access more robust.
Makes sense.
And third, critically, map out at least one real safety pathway end-to-end for an AI application you use or are building. Define the failure modes. What happens when it goes wrong? And what's the human handoff procedure? Plan for failure.
Excellent practical advice. So a final thought for people to chew on.
Given those really striking efficiency gains we saw this week, Kimi Linear slashing KV cache, column M potentially changing next token prediction, here's the question. If the cost of actually running these models, the inference cost, starts to plummet towards zero, does the main competitive advantage shift away from just owning the massive compute infrastructure? Does it shift towards the developers who can build the most sophisticated proprietary agentic workflows on top of that now cheap inference? Where does the value accrue next?
That's a fascinating question. When inference becomes essentially free, what becomes the moat? Definitely something we'll be watching closely in the coming months.